Hello, I'll continue talking now about IP version 4 subnetting, and this is part 2. Now we were given this IP address of 10.13.14.16/17, which is also 10.13.14.16 with the subnet mask of 255.255.128.0. Now what does 17 or /17 mean here? This means that the subnet mask is telling us that 17 bits will be used for the network or the subnet, and the remaining 15 bits will be used as the host portion. Now the IP address we were given in decimal is 10.13.14 and .16. This is our IP address in decimal. When we convert it to binary, this is our IP address in binary. And as for the subnet mask, which is 255.255.128.0, this is when we converted from decimal to binary. And now this is telling us that /17, that 17 bits here are our network portion, and the remaining 15 bits, this is our host portion. Now, the IP address, we will convert only the first two octets on the right, 10.13.14.16, and this is our subnet mask. Also, will convert only the first two octets. Now, if we put this line between the network portion and the host portion, we will have here 8 bits on the first octet, plus 8 bits the second octet, and only 1 bit from the third octet. This is our network portion. Now the third bit, we took only 1 bit towards the network portion. The remaining bits in the third octet towards the host portion, 7 bits plus 8 bits. This is our 15 bits, the host portion. Now the subnet mask, here the subnet address, if we want to configure the subnet address, the rule says that we fill the host portion all with zeros as we learned in part 1. So when we fill this host portion with zeros, this gives us the IP address for the subnet or the network of 10.13.0.0. And as our first host address, the rule says that we fill the host portion of zeros except for the first bit, which we set it up to a 1. This is for our host address, first host address. And when we convert this from binary to decimal, this gives us 10.13.0.1. And as for the last host address, we fill the host portion with ones, the whole bits in the host portion with ones, except for the very first bit. We set up that bit to a 0. Now when we convert this from binary to decimal, it gives us this IP address of 10.13.127.254. And as for the broadcast address, the rules is saying that we fill the host portion with binary ones. Now when we convert these binaries to decimal, this gives us 10.13.127.255 as our broadcast address. Now the IP address consists of 4 octets. Each octet consists of 8 binary bits. These are our bits on the IP address when all the bits are turned off of zeros, and this is the same when the whole bits are turned on. Now we have in the first octet 8 and plus 8 in the second octet, plus 8 in the third octet, plus 8 bits in the fourth octet. This gives us 32 bits in the IP version 4 address. Now, in each octet, like this octet here in the first octet on the left, the value of this octet is 100. The value of this bit in this octet is 128, the first bit on the left. The same if we want to know the value of the bits on the third octet, the same after the dot. This bit here, the value of it on the third octet, also 128. Now if we move to the second octet on the right, let's us choose the third bit here. The third bit in this octet, the value of it is 32, and so on and so forth. So now for each octet, each bit on each octet, the values, like the first bit on the left is 128, the second bit is 64, the third bit is 32, the fourth 16, the fifth is 8, the sixth bit is 4, and the seventh bit is 2, and the eighth bit is 1. Now, as I said, in this table, I put the values of each bit in one given octet. Now, if we have only one, the first bit in an octet is turned on and the rest of the bits are turned off, the value of that octet is 128. Now, if we have two bits in that octet are turned on and the remaining bits in that octet are turned off, so 128 here in the first bit in the octet plus 64, this gives us 192. This is how to read it. Now if we have the first 3 bits in the octet turned on and the remaining are off, this is how to count it. 128 plus 64 plus 32, and this gives you 224, and so on and so forth. Just if you look at this table here and try not to memorize it, just know the values of each bit in each octet and try, just to say if this bit is turned on and this is off, and just do your calculation. Just add the bits up and you will get you will end up with the value of that octet. Now we will learn how to subdivide a network to specific hosts or specific networks as required. Subnetting involves taking bits from the host portion of a given address and then allocating those bits to the network portion of the new address. This is how to create a few subnets out of a single subnet. We have two formulas. Now, when asked for specific numbers of hosts, we use this formula. For the host, it's equal to the power n minus 2, y minus 2, 1 for the network address and another for the broadcast address, because for each network, one will be for the network, and this is reserved. You cannot share it with another a host, and the other one is the broadcast address. That's why we have the minus 2. Now, when we are doing the counting for hosts, we do the counting for bits from the right to the left. Host equal 2 to the power n minus 2. The 2 is the base of binary numbers, as we learned in previous videos, and the n is the number of bits left for the host part, because first you will configure the network and then the remaining, this will be for the host part. When asked for a specific number of networks, we use this formula, network equal 2 to the power n. When we are doing the counting for networks, we do the counting of bits from left to right. 2 is the base of binary numbers, and the n is the number of bits borrowed from the host part. Now, we have this table here, 2 to the power n and the value. Now, 2 to the power of 1, this is giving us 2 to the power 2, 4, 3, this gives us 8, 2 to the power 4 is 16, 32, 64, 2 to the power 7, 128, 2 to the power 8, 256, 2 to the power 9, 512, 2 to the power 10, 1024, and so on and so forth. Now, we have this example. We were given this subnet IP address of 10.10.1.0/24. Now, we were prompted to subdivide the subnet into smaller subnets, and each subnet needs to support 14 hosts. Because it's asking us for numbers of hosts, I will use this formula, 2 to the power n minus 2. And we say, as we said previous, that minus 2, this is 1 for the broadcast and the other one for the network IP address. And now we count the host bits from right to left. We need to configure how many bits are needed to cover the number of hosts that will support 14 hosts. Now 2 to the power 4 minus 2, this gives us 16 minus 2, which equal to 14, which we been prompted. So 4 binary bits are needed to support 14 hosts per subnet. Now pay attention here. We know that at this point that we need to take only 4 bits from the host portion and allocate them to the network portion to create subnetwork, each with 14 hosts. The subnet we were given is 10.10.1.0/24, which is 10.10.1.0 with a subnet mask of 255.255.255.0. The subnet mask told us where is our network portion. 10.1.0 10.10.1.0 with a subnet mask of 255.255.255.0. This is up to here our network portion, and the 0 here, the 4th octet, this is our host portion. So we will be working on the 4th octet here on the host portion. We will be working on the last octet, the host portion, and because we want to configure the numbers of hosts per subnet, we count the 4 bits we configured from right to left. So here we have this, our subnet. We will put a line there because we will not work on the network portion. We will be working on the host portion. So the first 0, the second, and the 4th, this is our host portion and the IP address. The given original network is this, 10.10.1.0/24 or 10.10.1.0 with a subnet mask of 255.255.255.0. The subnet mask is /24. After configuring the number of hosts per subnet, we got 4 more bits to count towards the subnet mask for our new subnets. So we worked already on our host portion. Now we need to work on the subnet. So we write down the IP address and we put a line here to separate the host portion from the subnet portion. And this is our host. Now for our subnets, if we put all the value of the bits to zeros, this is our subnet. 24 bits here and plus 4, and so the subnet mask for the subnets is 28 bits because the given subnet mask was 24, and after we did the formula we have extra 4 bits, so 24 bits plus 4, this gives us 28 bits. Another quick way to configure the subnet mask, the IP version 4 is 32 bits in length. Minus 4 bits were allocated to the host portion. This gives us 32 minus 4 equal to 28, and this is our subnet mask. Just use either or way, you will be fine. Now, I will configure the subnets. Now we have the network of 10.10.1, and we will be working on the first octet, the host portion. This is for our subnet. We draw a line there to work on the subnet side, and this is for our host portion, which we configured, or we know already we will have only 14 hosts per subnet. As for the first network, we write down the IP address like this. We will be working only on the first octet on the right, and we will not touch for now the host portion. We will work on the subnet portion. So we draw 2 lines here, and we fill for the first network the subnet portion of zeros. So our first network, it will be 10.10.1.0/28. 10.10.1.0 with subnet mask of 255.255.255.240. As for our second network, we do the same. Our IP address, we write down the host portion, but we don't touch it. We draw 2 lines here to work on the subnet for our second network, and we put a 1 for the first octet in our subnet portion, and we fill the rest with zeros, as you can see here. When we convert this, the first octet in the IP address, when we convert from binary to decimal, this gives us for the first octet the value from this binary to decimal of 16. So the second network of 10.10.1.16/28, 10.10.1.16 with a subnet mask of 255.255.255.240. The third network, the same, we write down the IP address. We will be working on the subnet portion here. We fill the first with 0 and the second with a 1, 0, and then a 0. This, when we convert it to a decimal, this gives us 10.10.1.32, because when we convert from binary to decimal, this is all our bits in the fourth octet, and the value of this bit here is equal to 32. This gives us 10.10.1.32/28, and with a subnet mask of 255.255.255.240. The fourth network, we do the same. We draw two lines to separate the host portion from what we want to work on the subnet portion, and we fill the 1 and then another 1 and then a 0 and then a 0. When we convert this from binary to decimal, this gives us here for the first octet the value of these two bits here being turned on, or 1 is equal to 48. So the network, the fourth network of 10.10.1.48/28, and which is 255.255, or the subnet mask of 255.255.255.240. And we need to do the last network. We fill the whole host portion of ones, 1 and a 1 and a 1 and a 1 here. And when we convert this from binary to decimal, this gives us 10.10.1.240/28, and subnet mask of 255.255.255.40. Now, we were asked to have 14 hosts per subnet. We followed this formula of 2 to the power n minus 2 to configure how many hosts per subnet. 2 to the power 4 minus 2, which is equal to 16 minus 2, and this is our 14 hosts. And we have 16 subnets when we follow this formula of 2 to the power n, which was 2 to the power 4, which gives us 16 subnets. 16 subnet and 14 hosts in each subnet. Thank you so much for watching, and I'll see you in my next video.